Hello, and welcome to the Biomass Magazine podcast. I am your host, Anna Simet. Today we have with us Andrew White, CEO and co-founder of CHAR Technologies, a clean tech company specializing in high temperature pyrolysis. Andrew, welcome to the podcast. Thanks for joining us today.
Thanks for having me. It's a pleasure to be here.
Absolutely. So I think let's start today with you telling us a little bit about the background of CHAR Technologies and what you guys are all about.
For sure. So as you mentioned, high temperature pyrolysis is primarily what we're all about, and we can talk about that further. But basically, it's heating material up in the absence of oxygen at high temperature, 800 degrees Celsius, so about 1600 degrees Fahrenheit. Creating biochars and creating renewable gases. So we're able to capture things like green hydrogen or renewable natural gas from the process. But a little bit kind of about us, where we came from. The company was founded actually based on research I was doing at the University of Toronto, finishing my master's in chemical engineering. Back in 2010 is when I defended my thesis on converting a very specific feedstock called digestate. It's like the compost that comes out of an anaerobic digester, and turning that into activated carbon to then clean the biogas that comes out of that anaerobic digester. So a real focus on, kind of the circularity, using this low value residual to make a higher value product to then clean the gas at that same facility. So that was back in 2010. Launched the company in 2011, got our first round of funding in 2013, and by 2018 we had built our first facility in London, Ontario, taking digestate and creating this activated carbon we called sulfachar. And then around the same time, since it was a larger facility, we started looking at other feedstocks, so things like wood residuals. So, being in Southern Ontario, we're looking at wood waste, things like pallets, and then we're able to bring down wood chips and bark and sawdust and different nutshells and miscanthus and a whole host of different fun materials, and run it through the system, find out what types of carbons or what types of biocarbons we could make and what kinds of gases we could make. So our plant always makes these two outputs, gases and biocarbons. The biocarbons generally we categorize into biocoal. So for us, that means metallurgical coal replacement, so very high quality, high spec, generally focused in steelmaking, replacing fossil coal in steelmaking. Or biochar, so in that case with the cork market, it's become quite an attractive area for carbon production. And then simultaneously the gas, like I said earlier, we can either take it down the pathway of making green hydrogen or renewable natural gas, but always one gas and always one biocarbon.
Really interesting, Andrew. So tell us a little bit more about the technology, how it works and testing that you guys have done, feedstocks that you can use, and so on.
For sure, and because I'm assuming sort of Biomass Magazine is a generally broad audience, I like to start now with what I call Thermochemical Conversion 101, just to really highlight kind of what all the different technologies are and how they're contrasted, and each has their own place. I'm not saying pyrolysis is better necessarily, but it's all about what you want to make and what you're putting in the material. So, everyone's familiar with combustion. That's basically burning in, high oxygen environment. You got lots of air to burn that material. It's used in sort of, typical boiler, power generation, fluid beds, whatever. You then move a little bit to the right and you've got gasification. So now instead of having lots of air, you've got a little bit of air. So you burn some of that material, but you don't burn all of it. So now you can start to create different biocarbons and different gases. It's actually basically the way charcoal has been made for, X thousands of years. You'd light some of the wood on fire, you'd pile a bunch of wood on top of it, you'd pile dirt on top of that. So you limit how much oxygen is present, and now you start to do this thermochemical conversion where you're converting material and not just burning it. And then pyrolysis, there's sort of a whole bunch of different categories. What we do, we call it high temperature slow pyrolysis. So high temperature, like I said, 800 degrees Celsius. Slow means our resident time's about 20 minutes to 30 minutes. Pyrolysis is without oxygen, so we're heating up basically a tube that we have airlocks on, so no oxygen is in the system, so now nothing can burn. It just gets fully thermochemically converted, so that means it breaks apart into a gas and a fixed carbon. And then that sort of comes out. And depending on what you're trying to do and what you want to do, you can use any of these three types of conversion technologies. For us, because we want high quality gas that we can further take to green hydrogen and renewable natural gas, it's crucial that we don't have any oxygen or any air in the system. And that also allows us to control the quality of the biocarbon. So we can get biocarbons with like 90% fixed carbon, which is why we can then look at replacing high quality metallurgical coal in things like steel making. So what we're making, so both this gas and this biocarbon, we can vary our process because we're heating it externally. We can change the temperature, we can change the residence time, and we can really tailor what we're making. But a lot of those decisions are based on what the feedstock is. So to your question, Anna, about feedstock, if we're running, wood shaving versus a bark versus a piece of pallet wood versus a miscanthus, we'll change the control parameters a little bit, and the biocarbon quality will change. So what we can do with that carbon will be different, and sort of exactly how we want to make the gas will be different. But from a biomass perspective, we've done the cleans, like I said, nice clean wood chips, nice clean wood shavings. We've tried some bark. We've done different qualities of construction demolition wood. Obviously, we want higher quality. We don't want a lot of things like drywall in there because that'll create sulfur issues for us. So we're a little selective there. On the energy crops, we've done a few runs with miscanthus, which actually create a really, really nice carbon. And then we've gone to even more interesting things, like we've done work in the digestate, the composts. We've even done some work in biosolids. When we get to those types of materials, the added benefit is the destruction of something called PFAS, which is polyfluorinated alkyl substances, but basically one of these forever chemicals that, if you go watch the movie Dark Waters, it's all about it, but it's in things like biosolids. And a side benefit of high temperature pyrolysis is we're able to destroy those PFAS elements. So we've played around with a whole host of materials. We've got internally a really robust library of, what are we putting in the kiln? What temperatures and residence times are we doing? What's the quality of the gas? What are the main components? Things like methane, carbon monoxide, carbon dioxide, hydrogen. What are some of the minor gas components? And what's the quality of that carbon?
Mm-hmm. Very well explained. Thank you, Andrew. So recently, the government of Canada invested $1.5 million to support your Thorold Renewable Natural Gas and Biocarbon project. What are the details of that project? I know you're building out in phases. Is it under construction yet?
It is, and actually we've hit a reasonably major milestone in phase one, which is phase one of the project is basically moving our existing facility from London to Thorold so that we're in one location. The site we were on, we had fantastic site host, but we were in a relatively tight envelope. We had a 2,500 square foot building and a little bit of space around the building. So we're now in a 17,000 square foot building, and we've got about 50,000 square feet of space around the building. It's actually pretty cool. It's at a former pulp and paper plant. So we're, kind of going into biomass processing. We're just making, biocarbons and renewable gases instead of paper, but we're kind of, reusing this facility that's always processed wood in one way or another. With our plant moved, the kind of capacity of that system is around, depending on how we operate it, between 1,000 and 2,000 tons a year of biocarbon. So it's enough for trials and the like, but we really want more production. So phase two of the project will be expanding our capacity, building larger processing kilns. That's what we call our pyrolysis unit kilns, and getting that production up to about 12,000 tons a year of biocarbon. And simultaneously, we'll be then adding the renewable natural gas component. And once fully commissioned, we expect the plant to be producing about 500,000 gigajoules a year of renewable natural gas.
Very exciting. So I know that you have additional projects in various stages of development, one in Quebec, in Kirkland Lake, Ontario, and California. Can you talk a little bit about those?
For sure, and really the Canadian projects that we have are building off of what we're doing in Thorold. So Thorold will, we're not the only ones doing biomass to RNG, but this will be, when commissioned, the only operational plant of its size in Canada making RNG from biomass. And we're constructing it, which is super exciting for us. Saint-Félicien in Quebec, it's not too dissimilar. We're actually co-locating with a cogen that uses biomass, so we're able to leverage a lot of the feedstock handling, truck scales, grinders, truck dumpers, et cetera, to produce biocarbons and gases. In that case, the way we approach projects is modular. So the Thorold project, when we do the expansion, is 2 modules. Saint-Félicien will be 1 module. Kirkland Lake will be 2 modules. So Saint-Félicien and Kirkland Lake are in development. So we're doing the detailed engineering. We've got LOIs in place for feedstock. We've got land option agreements in place for where we're going to build the facility. So we can move, actually, I think, quite rapidly with Thorold getting through construction into those projects as well. And then the California project is kind of unique. It's with Hitachi Zosen and Nova. And in that case, we're building the plant on the back end of their existing anaerobic digester. So, Thorold is woody biomass, wood waste, pallet wood. Saint-Félicien is wood residual. Kirkland Lake, being in northeastern Ontario, is wood residual. California is anaerobic digestate from their biogas plant. And in that project, we're just finishing the fabrication of the kiln, get that deployed and move that project along. So these projects are all real, and they're all moving. Thorold's under construction. California is in equipment procurement and permitting, and Saint-Félicien and Kirkland Lake are both in development with land options, LOIs for feedstock, LOIs for offtake, and just doing the detailed engineering now.
Very exciting. Did you notice I avoided trying to pronounce that city name? I just let you do it.
Saint-Félicien?
Yeah.
And I mean, it might sound okay. I mean, I'm sure any Quebecers listening will cringe when I say it as well, but I do my best.
Sounded good to me. So I just have a couple more questions left for you, Andrew, and let's shift gears just a bit. What's demand like right now for biocarbon? Could you talk a little bit about that?
Yeah, I mean, I would say demand is phenomenal. And there's I think a couple of big drivers behind it. So, there's kind of all sorts of biocarbons, and there's all sorts of ways people use nomenclature to describe different carbons. So I'll just sort of briefly pause and say, for us, biocarbon is the overarching term. So anything coming out that used biomass of some kind, we call it biocarbon. And then based on how we made it or what its attributes are, we'll say, this is bio-coal if it's going into a coal replacement pathway, and it's biochar if it's going into land application and generating carbon credits. So that's kind of my nomenclature. I think that's generally where the world is drifting towards, but I don't think it's fixed yet. So just to be kind of clear when I speak, that's what I mean. So on the bio-coal side, particularly in the Canadian context, heavy industries are, really making tremendous progress to decarbonize, to reduce their GHG emissions. But, there's some processes like steelmaking where solid carbon is a critical part of the chemistry that happens in that reaction. So yes, there's changes in steel from going from these blast furnaces that use a lot of coal to some of these other furnace technologies that don't use as much coal for heat, but they still need solid carbon for the steel making process, for the chemistry. And so your two options are a biocoal that meets the strict spec of steelmaking, or fossil coal. And when we look at GHG reductions on a life cycle basis, switching to a biocoal is 92, 93% GHG reduction. And particularly in the Canadian context or the European context, when there's a price on CO2 emissions, reducing that number makes a significant difference. And to put it in context, if you have a steel plant consuming about 50,000 tons a year of coal for an ingredient, in Canada by 2030, they would be paying about 25 million in carbon pricing if they were using coal. So there's the demand, and there's the delta is that they have to pay the commodity price for coal plus 25 million, or they can buy biocoal and reduce those GHG emissions. On the biochar side, I think the big driver that has really kicked the industry forward is the ability to generate these voluntary carbon credits called CORCs. And a CORC stands for Carbon Dioxide Removal Certificate. And basically, it's a voluntary carbon credit. So it's kind of conceptually the same idea as tree planting used to be for generating these carbon credits. The big difference is traceability. So when you make biochar, you weigh it as it comes out of the kiln, you know where it went, and you know where it was field applied. So the traceability is very much there, whereas with tree planting, it's kind of been a bit wishy-washy. So when large companies are looking to make ESG investments, they're looking to invest in carbon reduction. Buying corks through biochar is a really great way to do it. And the way to conceptualize this and realize why it has such benefit is it's part of kind of a natural carbon capture and sequestration cycle. So let's use, woody biomass as our example. The tree captured CO2 from the atmosphere to grow, obviously. The bulk of that tree went into building materials. The residuals from that process gets turned into biochar. That biochar is a fixed carbon, so it's not going to degrade. If you leave a slash pile in the forest, it sort of will decompose into CO2 and methane. That fixed carbon, that biochar doesn't degrade. You put it in soil, that carbon is stuck in the soil now. So it really is a clear pathway to sequestration. And I think because of that, the marketplace has really been going. And, to again put numbers around it, the last time I checked, the cork price was around 150 euros. And when you're using woody biomass to make biochar, 1 metric ton of biochar gives you about 2.2 carbon credits, which means 1 metric ton of biochar is giving you 300 euros just on the sequestration benefit. And then you get added value from its agronomical value. It's creating surface area in the soil. It's letting, all the soil microbiology have places to hang out and do all their good stuff. So because of that, you're seeing large industries in the sort of high-tech space like Microsoft and Shopify buying corks. You're seeing oil and gas players buying corks. You're seeing, anyone and everyone looking to potentially buy them. And, to kind of demonstrate one of the marketplaces, now there's a few marketplaces, but one of them is called Puro Earth. And, NASDAQ's putting, their kind of seal of approval, their money, and their heft behind that marketplace. So, I think the market is growing quite rapidly, which is very, very encouraging, of course.
Yeah, absolutely. This is such a fascinating topic. I think we could probably continue talking about it for another hour, but I will get to my last question, Andrew, which is, taking a long-term view of things, what's on the horizon for your company? Any other plans or long-term goals you would like to mention, or really just anything else that you want to add before we wrap it up?
Yeah, I mean, for us, I think in all of the outputs, so kind of to bring it back to how the technology works, we're always making these two output products. We're always making a renewable gas and we're always making a biocarbon. And I think both of those outputs are growing in demand. When we look at renewable natural gas, the ability to really meet the demand using woody biomass is huge. I mean, the entire production of renewable natural gas right now in the United States, which is generally done through anaerobic digestion, not pyrolysis, but once it's renewable natural gas, it's renewable natural gas. That entire U.S. production is only enough to meet British Columbia and Quebec's demand in 2030. So there's a huge supply-demand gap. And then when we look at forestry products, and I apologize, I'm going to switch units because I don't have it in front of me and I can't switch from MMBTUs to petajoules. But when we look at the capacity to make renewable natural gas in a province like Quebec, which has lots of forestry, I'll certainly acknowledge that. You can make about 25 petajoules of RNG by 2030 using sort of organic waste. And that number grows in aggregate to 140 if you start adding woody biomass. So the ability to use woody biomass to make RNG and to meet this enormous demand on the gas side is phenomenal. I think on the carbon side, whether it's the sequestration using biochar or the GHG reduction through fossil coal replacement is huge. And so what we're doing is we're going to continue to build out our own projects that are similar in scope, scale, and size to Thorold. Build it in Kirkland Lake, build it in St. Felicien, build it in a few other locations. And the scalability thing, we have the ability to be big enough that we get reasonable economies of scale from the equipment, but small enough that, we don't suffer from the reverse economies of scale of trying to pull in biomass from too far away. These plants are needing 70,000 or 100,000 tons a year. We're not talking millions of tons a year because I think that becomes a bit untenable from a logistical perspective. So it's this distributed model. So that's really what we're doing. That's what we're going to execute on. And, we've got a plan kind of by 2025 to at least have, projects either built or under construction to have 2 million gigajoules of RNG kind of getting out into the market. And that's a very achievable goal for us. And that'll make a really big impact in the climate fight as well. So I'm really excited about where things are going right now.
Very exciting. Andrew, thank you so much for joining us on the podcast today. Been really interesting, and it's been a pleasure chatting with you. And I hope you'll come on again sometime next year and give us an update.
Absolutely. I'd love to. The pleasure is mine. Thanks so much for having me.
You bet. And to our listeners, thanks for tuning in. Hope you've enjoyed this episode. Until next time.